So in this vectors assignment 12, this question here, which was a previous exam question, you were being given a triangle which had two vectors on it, A and C, and then this is really like a 3D diagram because the vector B is a vertical vector compared to A and C, and it's perpendicular to A and C. So we are being asked to work out this scalar product, so we begin by treating the bracketed term with the A dot part at the front of this as if you are multiplying out the brackets. So what you want to be writing down is that is going to become A dot A plus A dot B plus A dot C. And if you've written that out, that earns you the first mark. What you're then doing after that is interpreting the scalar product and the standard result, that if you're doing a vector dotted with itself, because the angle between the vector and itself is 0, you get the cos 0, so you end up with just being the magnitude squared. For A dot B, you'd have magnitude A, magnitude B, cos. Now the angle between A and B tells you that in the diagram it is 90 degrees, and then you've got magnitude A, magnitude C, cos. Now between A and C there's no angle marked on the diagram, however if you read through the whole question it tells you that A and C are two sides of an equilateral triangle, and in an equilateral triangle everything is equal. So that means all your angles would need to be 60 degrees. So when you're doing the cos for between A and C, you're doing cos of 60. So from our numbers in, or the information, the magnitude of A was 3, so you're doing 3 squared. The magnitude of A was 3, and that's getting multiplied by magnitude of B is 2, and the cos of 90, right, this was an unknown calculator paper, so just in case you can't remember, you could always draw the graph to help you. Remind yourself that at 180 you're down at -1, so this point here would be 90, so the cos of 90 is clearly 0. And then for A times C, they are both 3. And the cos of 60, you could do your 60-30 triangle to get your numbers out for this. So you've got 1, 2, root 3, and of course the cos of 60 is a half. So we would have 9 plus 0 plus 9 over 2, or 4.5 plus 9 is 13 over 13.5 rather, or you might want to write it as 27 over 2. The other marks awarded in this piece of work is that you get a mark for the 3 squared, the A squared bit. That's really like your second mark. Your third mark is for the magnitude of AC, so this one here. That would be your third mark, and your fourth mark is really for the final answer, together with the 0 as well for the A dot B. So that's how you'd earn yourself 4 marks in that particular question. So the next question for this, you need to make sure you read all your information here. So to begin with, right, part A, you've got two vectors A and B, got two different magnitudes there, you've got an angle of 45 between them, and you're asked to evaluate A dot A. So using your standard result, that would be magnitude of A squared, which would be 3 squared, which would be 9. The second one that you were asked to find is B dot B, which is magnitude of B squared. And for this, because you're dealing with two terms, you've got 2 root 2 squared. That's actually going to be 2 squared times root 2 squared. So you're going to have 4 times 2 so that comes out to be 8. And then the third one that you had to work out was A dot B, and by definition, to work out your A dot B, that would be your magnitude of A, magnitude B, cos the angle between them is of course 45. So you would have 3 times 2 root 2 times my cos 45. Again, you might need to draw your wee diagram to help you. You've got 1, 1 and root 2, so it's 1 over root 2. You can of course cancel your root 2's and you end up with the answer of 6. Now there were only 2 marks awarded there. How you got the marks for that particular one, you got the mark for 1 and 2, so this one and this one together. Right, so 1 and 2, you needed to get both the 9 and the 8. That was the first mark. And then you had to get the third one, would be your second mark, your A dot B. Now then for part B, which is a wee bit harder, you are being given information about a new vector P, which is made up of scalar version of 2a plus 3b, and you're asked to evaluate P dot P and hence write down the magnitude of P. So you begin by working out what P dot P would need to be, and you've been given an alternative expression. So you've got 2a plus 3b, and that is dotted with 2a plus 3b. Your vector should be underlined, of course, and then just standard practice to multiply that out. You're going to get 2 times 2 is going to be 4. You're going to have 4a dot a. Then your middle term, you're going to have 2 times 3 is 6a dot b, plus 3 times 2 is going to be 6b dot a, and the last term is going to be 9b dot b. These two middle terms, a dot b and b dot a, are the same thing, so you could just have written this as 4a dot a plus 12a dot b plus 9b dot b. Now notice that our answers in part A allow us to just now write down that a dot a was equal to 9, so we just simply need to do 4 times 9, and your a dot b was equal to 6, so we just need to do 12 times 2, and your b dot b was equal to 8, so we just need to do 9 times 8. So you have 36 plus 72 plus 72. If you add all of that up, you end up with 180. So your marks awarded, we've still got one other bit to do, but the first 3 marks are from here. So 1 for replacing the P terms with a 2a plus 3b in a dotted format like that. The second mark is really for then multiplying out the brackets but still having the dot product included, and the third mark is clearly your value for P dot P. Now by definition, because P dot P is equal to the magnitude of P squared, and we've just said that P dot P is also equal to 180. Put those two facts together, you get magnitude of P squared equals 180, so the magnitude of P will be the square root of 180. It is then a matter of seeing if you can simplify. That does simplify into square root 36 times 5. If you didn't notice that and you said, oh, I'm going to split it up into root 9 times root 20, you would get 3 root 20, but actually your root 20 would then split up further into root 4, root 5. Square root of 4 is 2, 3 times 2 is 6, so you'd get 6 root 5. You could get there a bit quicker if you spotted that you could write the square root as root 36 times root 5, and that does give you the 6 root 5 as well. However, I'm going to say that if all they're asking is the magnitude of p, you could just leave it like that. You'd only need to do this if it said express this bit here with the 6 root 5, if it said express your answer as in third in its simplest form.